Good day to you. This is Anna Galactic bringing you a special presentation on superposition. Superposition. Well, we know what the prefix super means, and we know what position is, and we know what logic is. So what could it mean to have a logic of superposition? Well, the prefix super is just a little misleading because of the way it's been used in the past. The Latin prefixes sometimes have more than one meaning. I myself use a Greek prefix, ana, A-N-A, which has by far the most confusing system of possible meanings of any of the prefixes either in Greek or in Latin. Ana can mean anything from around to anything that sounds like it's around. So I like Anna, and I like Anna Galactic, which used to be a word. Lundmark tried to popularize it, and several other men utilized it in the, I believe it was the 20s and 30s, but it fell into disuse. But you can still find it in the Oxford Dictionary. Anna Galactic has an actual meaning. It generally means supergalactic. Where super simply means a larger of something. For instance, Superman means a man with additional capabilities that a man would not ordinarily have, such as the ability to leap over tall buildings and to see through women's clothing. They would sell the X-ray glasses in the DC comics. We were only like 10 or 11 years old when reading this, but we still wanted those glasses. But you know, it's $2.50. You have to ask your mom for money, or well, she'll tell you to mow the lawn, and then forget it. Especially when it's as hot out as it is right now in Chico. Forgive my appearance, but it's in the hundreds. So anyway, sorry for my appearance, but I'm trying to keep cool. I already made one presentation today, but then when I played it back, I forgot that the air conditioner was going. Unsuitable. Unfortunately, I have to redo it, but then it's always a good idea to do two presentations if you have time, because the second one is going to be better. Alright, so superposition is somehow beyond position. Well, in this case, super does not mean greater than, it means an additional layer. So instead of there being an unambiguous position on which science relies, the position is not quite exact. The way this comes up in physics is how the term came into vogue was because of a physical phenomenon. So what is superposition in physics? Of course, it's a quantum phenomenon. The nature of superposition can best be visualized in the famous entanglement experiment, where it's important to realize that the word entanglement is, strictly speaking, incorrect, because it's not entangled. The entanglement is an artifact nuance of the logic entanglement. That's where the term entanglement originated. The logic is entangled with an extra gate. So there's such a thing as superpositional state logic, referring to the superpositionality of two particle states. So what does that highfalutin phrase mean? When you coordinate two particles, it's called entangled, but it should be called coordinated, and then they're separated in space. It has been proved, almost certainly, that when the two coordinated particles are then measured, you take a measurement on one, there should be an event lag. Because of the spatial separation, space-time, essentially relativity, this is the definition of relativity, that two spatially separated particles also have an event separation. That we accept that. That's why we measure light years of distance. Light year is really, it's light distance, but we say light year because the distance is measured in time. and the time is measured in distance, so they're correlated. It turns out that that is a linear correlation, and that's why the redshift of light indicates distance, because the redshift is linearly related to the linear distance. That's very interesting, isn't it? So therefore we get a straight line distance to very distant objects, galaxies, objects much further away than our local stellar system. But there's a time lag, even to stars. Light years, of course. This becomes mega light years in cosmic space, but it's still light years. So, relativity formulates that by asserting that there is a linear relationship between spatial separation and event separation. I trust that makes sense. It should. But in superposition, when you create the spatial separation between the two particles which now have a coordinated state, when you take a measurement on one, it will fix the state in a predictable way, although this is with a different form of logic. But it's a probabilistic distribution, which is why this is a paradox. That should not be probabilistic. We should be able to say one way or the other what's going on between the two states. So that when we change one of the states by observing it, by taking a measurement, it fixes the other state. But in order for that to take place, there should be a time lag. It has been proved that there is none, which means that special relativity is violated. That brings into question, possibly, the formulation of space-time, because this would violate the premise of space-time. I wish to show to you today that with a proper reevaluation, geometrically, of what is meant by space-time, that superposition can be explained. If so, that would be the first time. The quantum paradox has never been explained. This so-called entanglement, which is superpositional coordination of state, this needs to be analyzed quite meticulously, and it has been, all the way down to the observer having an effect on reality, which is somewhat psychotic to say that, but scientists have been compelled to go out on a limb to try to explain this in some way. And the multiverse theory is simply an extrapolation on the paradox, as are parallel universes, all the way down to Schrödinger's cat problem, where the cat is both asleep and awake at the same time. In binary logic, that is not possible. But in the quantum mechanical paradox, the way Schrödinger sarcastically put it, you're dealing with something that your linear logic cannot explain. And in this case, our linear logic is space-time. Space-time is a linear formulation. So how do we deal with this event separation, which seems to be well substantiated, certainly in our ability to measure the distance to stars by a redshift of light, showing that the linear distance to that star is directly related to the linear offset of the redshifted waveband. I hope you understand that, even if it may have sounded like gobbledygook, it's not, but I'm compelled to be meticulous because these are formal presentations now. The way to explain that is very interesting, but it does require extending what we actually know to something that We just may have never noticed. So in that sense, we don't know it. Science does pride itself on building itself up on a firm foundation. But in this case, the glitch appears to be originating with the notion of space-time. You have to be cautious how you formulate space-time, because event separation is a different data type than spatial separation. So you could consider it a coincidence that the spatial separation of two particles entails a known time lag, which is violated by entanglement. That when you take this measurement, this state is fixed without any lapse of time. That is an illusion based on perpendicularity. And it's curious that you can actually see this. If you picture a circle, just draw a circle. Now tilt the circle until it becomes a line. Is that still a circle? Yes. But when you look at it, is it a circle? It doesn't look like a circle. It looks like a line. So you could say that the line and the circle in this perpendicular aspect, where you can no longer see the circularity, you would have to rotate it 90 degrees, or you would have to rotate it at all off of its plane in order to see that it's actually got another dimension. Well, that turns out to be exactly the situation with space-time. The reason that everything makes sense to us in space-time is that we're seeing space-time at macro scale, where quantum limits don't apply. And what we're seeing, this would be at the electron level. Generally, these two particles are either photons or electrons. The photons are a bit difficult to handle because they, of course, fall through space. But the electrons don't, so you can maintain their locality as you separate them. What is interesting is as you do this, you can prove that you're separating them in space, because you can take the measurement before and after. But what you do then, now that you have them at a known distance, you take the measurement on this one, which fixes its state. It changes its state, which forces the other particle to change state without a lapse of time. That only occurs at that scale, although tests have proved that that form of what's called entanglement, but actually is coordination, also occurs at the atomic level, and it's been demonstrated with what are called buckyball molecules, that entanglement also occurs at the molecular level, leading scientists quite naturally, I would say, to believe that superposition, which is virtually talking about the same thing as entanglement, they're superposed states. That's what superposition means. So that really is what we were after. So without going into any further detail, that is the physical basis of our common usage now of the term superposition. A logic system has been discovered which has an amazingly high level of correlation with superpositional physics, which, as I say, is very difficult to explain because it seems to violate special relativity. But does it? I want to show you a trick, a visual trick, and this is necessary in order to see through the paradox. Look again at the two coordinated particles. They have to be in a certain proximity in order for them to be coordinated. And the state coordination, you can think of it as a magnetic quality. where the magnetic pole can be, they're random, you see, with respect to each other until they're coordinated. Think of it as a form of polarization. And so now both particles are coordinated. But if you change this one, you see, you don't know, you never know exactly what state it's in. Although it is very difficult to describe. But you coordinate the two states such that you know what to expect when you change one of the states. Now you separate them. And now they're in their two coordinated states. But when you measure this one, you know it's going to change its state. And when it does, it will have an effect on this one. The question is there a time lag? It can be shown that when you change this one, the other one changes, but how quickly? Of course, this would be an excruciatingly difficult measurement to make. But it has been tried progressively over the decades, and it's considered now to have been successfully shown to a reasonable threshold that indeed there is no time lag, and that violates special relativity, so that needs to be explained. Let me show you. It doesn't violate relativity. But the only way to see that is to see the geometry of relativity. Let me show it to you. The two particles are coordinated now. Now you separate them to a known distance. Now look at that separation. You can see it, correct? Yes, you can. What about the event separation? According to space-time formulation, the event separation is also on this straight line. It's a straight line of event separation. That has a footnote. But is it? What is the actual relationship geometrically between the spatial separation and the event separation? In the case of a distant star in a galaxy, they're the same because they're at macro scale, because the quantum limit is not really being touched. And so it's safe to say that the linear distance is also the linear event separation. You don't say it's the same line, but you say that they're linearly coordinated. But what if they were at right angles? That's actually what Einstein said, is that time is perpendicular to space. That's the very basis of the Einstein field equation, is that they're orthogonal, they're at right angles. Well, what does that mean? You can't know what it means in linear space. It has no real meaning. But in spherical space, it jumps out at you. Let me show you. The two particles are now separated by a linear spatial separation. The predicted event separation is considered to be linear. But what if it were linear perpendicularly? Wouldn't that be exactly what Einstein said? Okay, so take a circle and now show the separation such that they're endpoints of a circle. In other words, that's not only a linear separation, it's a diameter on a circle. All right? This is new, so you'll have to trust me here for a moment. But now the linear separation is coordinated with a perpendicular event separation. They're both linear, but they're on perpendicular lines. Now, you can see both lines. Special relativity says that on the vertical line is your event separation, and they're directly correlated. They're linearly related. So as this distance changes, this distance changes. But this distance is between events. That's a different data type. Einstein proved that that's orthogonal, but nobody's noticed. What if you rotated this circle so that you cannot see the vertical line? Then you would only see the spatial separation. When the two particles are coordinated, what's happened is that their space-time coordinate system has been rotated so that you lose a degree of freedom. That's what it means for those two to be coordinated. You've lost a degree of freedom whereby the linear separation no longer exists in event space. There is no separation in event space because by coordinating them, you've turned this line so that you cannot see it. That means you will not measure it because it's not there, because it's not in space. You've coordinated the particles so as to reveal that temporal space actually exists, that event space is real. That's what superposition proves. What that means is we discovered the second dimension. We've only been using one dimension for over 2,000 years. We've been using a linear, systematic dimension. That does not correlate with spheric dimensionality. And so our 3D system for space misses by a mile. The actual structure of space cannot be captured with linear numbers. The actual structure of space, I proved in 2022 how we can gain access to the actual mathematics, the actual number system, and the actual geometry of physical space. No more intervening mathematics. Direct perception on a two-component proportional number system which correlates the space dimension with the time dimension, which I proved is actually the energy dimension. So what we cannot see is the energy dimension. That can be explained fully in hyperspheric geometry as our unique ability to see, that is our restricted ability to see the universe as it spins in. One of the two chiral directions that are balanced by the Noether force balance, which Bošković substantiated and to which I gave the number system in geometry, Noether, Bošković, and I are all on the same page. With a force dynamic system that reinterprets spacetime spherically, computably, rationally. This also solves the problem of infinity being irrational. I solved that problem by realizing that infinity is both imaginary and a boundary condition that can only be computed in spherical space. And from that we get the correct definition of the quantum and the correct definition of universal space. It solves the problem of the Big Bang, and it also solves the problem of the supermassive black hole, both of which are based on a singularity error. The necessary and logical restriction on the linear number system is where the right angle meets in linear space does not correlate at all. Well, it does not correlate adequately with the spherical orthogonality based on the radial line, which has a perpendicular line called the sphere. The radial line is the force line, which is either centripetal or centrifugal, and the spheric surface is light. That explains everything, and that's 25 minutes. It's in the hundreds here, so forgive me, but I'm beginning to perspire. And I'm here to have fun, not to work. So I hope you are too, because we're going to have more fun than a man should be allowed to have. He'll carry you all the way to heaven, even while you're in this flesh. If you think I'm kidding, stay tuned. Especially if you don't think I'm kidding, which I'm not. So, I hope you enjoyed this preliminary expose on what is superposition. I've given you the physical aspect. What's at least as exciting is the logic system. The logic system. It's superpositional with our ordinary logic system. In this case, super does mean superpower. So I hope you're ready for that. This goes in all directions prosperously. If you're excited by the beauty of the universe and you wish to have it justified at the foundational basis, you will need to go around modern physics, which has lost its way, in a linear labyrinth. I am the guide to bring you out of that quicksand. Stay tuned, this is Galactic, and keep looking up at night. This is a good time to look at the stars. We'll be right back.